All right, students. So we will do this numerical on the topic of radius of gyration. But the central theme of this question is not radius of gyration. Read the question first, take your time, and then we will solve this problem. I'll briefly touch upon the concept of radius of gyration. So let's read it through. It says that the angular velocity of a body changes from omega 1 to omega 2. So you have some rigid body, and this rigid body, for all you know, could look like this. Okay, its velocity, angular velocity changes from omega 1 to omega 2. And then this happens without applying the torque. Okay, so without applying, no torque. So no external torque, right? Which is good. Okay. And the ratio of the initial radius of the gyration to the final radius of gyration is being asked. Okay, so this is a body, and let me just reduce the size of the question now. I hope this is clear. You have to find the radius of the gyration in the two situations. Okay. Now, when you know there is no torque, okay, before I talk about, okay, so let's elaborate first on this. No torque means that I1 omega 1 is equal to constant. If there is a body with no external rotational force, okay, the product of the moment of inertia and omega remains unchanged, right? No external force, no change in momentum. No torque, no change in angular momentum. All right. Now, if you talk about the uh, radius of gyration, right, which is a key word here, radius of gyration. Okay. So, what is radius of gyration? So this is the whole body. Generally, what you do is you're given very specific figures like lamina, like a sphere, disc, and stuff like that. So that is, so you're able to find the moment of inertia of that body through some axis, right? And then you learn about parallel axis theorem, perpendicular axis theorem. But an axis is known, right? Passing through the center of the sphere, center of the disc. All those are standard things which you're going to encounter in your most of the questions. Okay, but here there is no such scenario. The only scenario is that the omega for the body changes, and if the omega of the body has changed, then what is the change in radius of gyration? Radius of gyration, what it means is if you concentrate the total mass of this body, at the radius of gyration. So this is your K, this is your M. And M is the mass of this rigid body. You convert this into single mass, concentrated here. So whatever the mass here gets concentrated here, and I think I'll have to reduce the size further so that I have ample writing space. All right. So if you reduce the size, and this is your, so the moment of inertia now can be written as mk squared. Okay? So this is the so-called second moment of inertia of the body. Generally, you write it like, you're given an axis which is tangential, which is passing through the center, or an axis like this, and you're expected to calculate moment of inertia, right? But there is another expression for moment of inertia of the same rigid body, which can be written as mk squared, right? Which is K is the radius of gyration. Okay? This is the length. Okay? So if you place the whole mass on the radius of gyration here, the whole mass is concentrated on the radius of gyration, then the moment of inertia you get is same as what exists for the body. Now let's use the knowledge of mk squared and the knowledge of this to calculate the overall, what is the ratio of the gyration. Okay, so let's say initially the moment of inertia was I1 into omega 1, and this becomes I2 omega 2, which means you change your rotation and the moment of inertia you have changed by moving the axis. You have done something, but you have not applied external torque, if you apply external torque, omega will change, but you will get angular acceleration. Right? Here we have to use law of conservation of angular momentum. So L remains conserved, right? Now, I1 can be written as M1 K1 square into omega 1 is equal to M. The mass on both the sides remains same because it is the same mass. Whether you keep it at K1 or you keep it like M or K2, right? Really doesn't matter because the increase or decrease in moment of inertia because of change in radius of gyration is compensated by a decrease in the, sorry, an increase in the angular velocity. So the angular velocity has gone up, I has to go down, and it is effectively be changed by changing the radius of gyration, right? So M on both the side remains same. This is K2 square into omega 2. So the M gets cancelled and omega 1 upon omega 2 is equal to K2 square upon K1 square, and K2 upon K1 is equal to omega 1 upon omega 2. Okay. This is the ratio of the velocity. So let's see what are the choices and what are we expected to calculate. Okay, so it is the ratio of the initial radius of gyration, which means we are supposed to find K1 by K2, right? So I will just write initial. So this is, I found K2 by K1. We are expected to find K1 by K2 is equal to omega 2 by omega 1. This is our answer. So you can see the choice number 1 is the correct choice. So I hope you like this question. Please go to my playlist of rigid bodies, rotational dynamics, and rotational kinematics to understand in depth the concepts. And a lot of problems have been solved from Resnick and Halliday, University Physics, Zemansky, and a lot of Indian authors have also been used. So thank you very much for your time today. Please don't forget to subscribe to this channel. You will see some excellent quality questions which are very exam oriented. The difference is these questions have a detailed explanation. So you can't talk to solutions, but you can understand explanation when you watch my videos. Okay. Thank you very much.